We're going to continue with uniform motion problems. Uh, Quick refresher on uniform motion problems. It goes all the way back to the formula. Distance equals rate times time. Those are what our variables stand for. Rate stands for speed. Distance equals rate times time. Well, in the past, lesson 22, I believe, we had these type of distance problems. It would say something like one student left at 9 a.m. from the school to get to Little Rock, and then another student left at, I don't know, noon to get from the school to Little Rock, and find the rate, time, all that stuff. Well, the equation we could use was distance 1 equals distance 2, because they're making the same trip. They were the exact same trip, so therefore their distance was the same. And then when we broke this down, because we need our rate and time variables, we turned this into rate 1 times time 1, referring to the first distance, equals rate 2 times time 2. And so then we would use this as our problem. So that would go in this format or this format. This wording would be one student left from CMA to go to Little Rock, and another student left from Little Rock to go to CMA. I know Little Rock's very broad, but nevertheless, they're traveling from the same place and making the same trip. So their distance was therefore equal. Now what we're going to look at is distance problems where that are a little bit different, but same equation. Say the wording was something like the school bus, okay, the bus traveled part of the way at 20 miles per hour, and then it traveled the next, it traveled, let's call it 20 miles at 20 miles per hour, then it traveled 30 miles at 50 miles per hour. Well, I know that distance is 460, but I think you get the point. Distance 1 plus distance 2 would equal 460. And there's 3 different ways to do that. You have the first one where they're just, all right, it travels part of the way and then finishes it. You have the second one where 2 people or 2 objects and whatnot are coming from opposite directions meet. It doesn't even necessarily have to be in the middle. It could meet over here and one person travel less. But when they are added together, it would still be 460. It would be the total. And then the third way would be they both started in the middle and they went their separate ways. They traveled a combined 460 miles, whatever it was. These are the 3 different ways, but our distance equations will be something like distance 1 plus distance 2 equals 460. And you could say that about all 3 of these. And then when we broke that down further, because we know distance is rate times time, we would go rate 1 time 1 plus rate 2 time 2 equals 460. And so that would work for all 3 of those. So let's look at one example problem for this. Example 29.1. And we're going to find some clue words that we need to look for in order to solve. It says Napoleon walked part of the 60 miles to the site of the battle and rode the rest of the way on a caisson, whatever that is. He walked at 3 miles per hour, rode at 9. The total time was 8 hours. How long did he walk? Okay, let's look for some clue words. Clue words. Let's see. Napoleon walked part of the 60 miles. Okay, first of all, part. Okay, walked part. So what that means is he did not walk the entire way. He only walked part of it. So if I was drawing a little graph, here's Napoleon. Okay, blue for the French. Here's Napoleon. It says he walked part of the 60 miles. Now, what does 60 miles refer to? Is that how far he walked? No. The 60 miles refers to the entire thing. So we could say 60 miles is going to be the total. Let's see what he did the rest of the way. Then he says he rode the rest of the way. Okay? The rest of the way is really the key there. It tells us, okay, this is his distance walked. He stopped walking, got tired, beckoned for a horse, or a caseman, whatever that is. I'm guessing it's a type of horse. I have no idea. And then this is the distance he went on the case. I'll put distance rode. Okay? That was a stopping point, but the total amount of distance traveled was 60. So this is how we can originally start it. And so what we can say is that distance walked plus distance rode equals 60. Then from there, always break that down further. Distance, we don't, it's not going to give the distance to us of each of these. That'd be too plain. So we got to break these down to rate walked, time walked, plus rate rode, time rode, and that equals 60. So we have broken down distance to rate times time. That's what we did right there. Now we got to look for some rates and times. So we got to look for these. I'll put this over here. Got to look for the rate of W, time of W, rate rode, time rode. So let's continue on. He walked at 3 miles per hour. Ding, ding, ding. What is that? Speed. So rate walked is 3. Got that. Rate walked. He rode at 9 miles per hour. Okay, so that's rate rode. Those are easy. Then it says if the total time of the trip was 8 hours, how long did he walk? So we need to find the distance walked. That's what we're looking for. But in order to figure that out, we're going to have to figure out, okay, it says total time was 8 hours. Total time, 8 hours. Okay, so those are some clue words. Total time was 8 hours. How could we write total time between time walked and time rode? Well, what you could say is the time walked plus the time rode equals 8 hours, because 8 is our total. So if 8's our total, it simply equals the sum of the time walked and time rode. Okay? So when you hear total time, total time equals the sum of your times. From here, time walked plus time rode equals 8. Well, that still doesn't give us an exact variable of time walked or time rode. What can we do? We could subtract one or the other to isolate a variable. So what I'm going to do is isolate TW and get it by itself by subtracting TR. And what that would give us is TW equals 8 minus TR. So we just move that there. Now we can plug in and solve our equation. So let's look here. Rate walked is 3. Time walked, we know that. Time walked is 8 minus time rode. Rate rode is 9. Time rode, we don't know that, but that all equals 60. We only have one variable of time rode. Therefore, we can solve. Start by order of operations in parentheses and distribute, or multiplication actually. Distribute 3 times 8, 24. 3 times negative TR is minus 3 TR plus 9 TR equals 60. Negative 3 TR plus 9 TR, 6 TR. Positive 6 TR. So from here, we're at this point, subtract the 24. Probably going to need to move this. Looks like I have a little room here. I'm going to write it here. 24 plus 6TR equals 60. Okay, we subtract 24. That would be 36 equals 6TR. Divide the 6. Therefore, time rode equals 6. Time rode equals 6. Plug that in over here. So if time rode is 6, what does that make time walked? 8 minus 6. 8 minus 6, we can all do that math, 2. Did we solve for what the question was asking now? That's what we got to check. Did we solve for what it was asking? In the end, it says, for how long did he walk? Okay, how long did he walk? So actually, my bad earlier, I was thinking distance walked. It was actually simply looking for how long did he walk. So that is not correct. So time walked is 2. So 2 would be your answer. 2 hours. 2 hours. If it did want to know the distance walked, all you would do is do time walked times rate walked. Find that that was 6. And find that he rode 54. So he rode a lot longer than he walked. Which is probably a good idea. 6 miles, that's a long walk though. Anyways, that's how you do uniform motion problems. You just got to get used to different clue words. So maybe these just take practice and trying to convert basically English to math in these word problems. So it just takes practice, but that is uniform motion problems.